I've already discussed how ridiculous it was for Steve Benner to align himself with Dave Farina, and I'm sure he's regretting it now. So here Steve Benner says in his little foundation there with Drs. Kim and Yondi that they've been able to make carbohydrates, that they've been able to make nucleotide triphosphates without human intervention. Well, we're going to see what he made. Now, here's what a spectrum of D-ribose should look like. I just got this from the internet. Now, D-ribose can have an open form, it can have a closed form, it can have a 6-member ring or a 5-member ring, depending on what state. And that's why you have a few little extra peaks here, but this is about what it should look like. Now, I'm going to show you from Benner and Kim's own paper what their D-ribose look like. Now, if you're a synthetic chemist, I'll bet I'm going to show you a C13 NMR. This is not a proton NMR. This is a C13 NMR of his reaction mixture. Now, synthetic chemists, I dare you not to laugh when you see this C13 NMR. I'll bet you can't look at this without smiling, and then you're going to start laughing when you look at the C13 NMR of the so-called D-ribose synthesis. Ready? Here it is. This is knee-slapping funny to a synthetic chemist. Here's what it should look like. Here's what Benner publishes. C13 spectra showing the formation of ribose borate from glycoaldehyde in C13 formaldehyde in the presence of borate. This is his mineral-guided prebiotic synthesis. This is what he gets. This is not noise. This is what noise looks like down here. This is not noise. Every one of these little peaks is another compound. Every one of them. It's just like your expert Lee Cronin said. Within seconds, you get billions of products. Remember you said seconds to an hour, you get
billions of products, literally within a few seconds or hours.
One of these is ribose. One of these in here is ribose. This is utter junk. And he claims he got it, and I claim it's probably in there. But you've got so many other things. You've got the enantiomer of that, you've got all the diastereomers, you've got the larger ones, the smaller ones, the solids that are precipitated out. You've got so much junk in there. It's just like Benner had said earlier. In this case, it needs ribose, so it's going to go to ribose. In another case, it needs another sugar. And so it's going to go to glucose in another reaction because it knows it needs that. So it's just going to go toward that, and everything else will go away. And the other enantiomer problem of that, the L-ribose, that's no problem. That would also sift out as well. So this is why I say, Dave, that what he's doing is irrelevant. This is absolutely irrelevant. Remember I said that they get a gazillion products. I just listed 6. No, I'm talking about 1 billion. And they see a little indication that it might be in there. And then what does he do? He goes on to the next step. Well, where did he get the ribose for his next step? Did he get it from here? No, it's impossible. Today, it is impossible with all our analytical techniques to fish that thing out. And somehow an early Earth did that in one of your little ponds next to the ocean. It was able to sift that thing out. I mean, think about that. See from my perspective why I say he didn't get it, and you say he did. But what he got was irrelevant, absolutely irrelevant. And now you synthetic chemists who look at C13 NMRs for a living, get up off the ground, just calm down. I know it's funny. I'm laughing with you. I mean, most people would hide this in the supplemental. But not Kim and Benner. I mean, they just put it on out there. Just unabashedly, they put this thing out there. But this is just laughable, utterly laughable. I bet Sutherland is laughing at this. Steve, you criticize John Sutherland's work? I mean, Sutherland may have 5 compounds that he might make in his human-involved reaction. You have 1 billion compounds in your non-human involved. You might want to start getting involved a little bit here. Dave, did you receive this as being a prebiotically relevant synthesis of ribose? I do not, because it is useless for any further reactions. It is a dead end. That's why I say it's useless. How prebiotically relevant is this? Well, we're going to see what's involved in getting DAP. Here he takes D-ribose, which he buys. He buys this from Sigmund Aldrich, not the stuff that Steve Benner made or that anyone else made. He bought it, and this comes from natural sources. These guys cheat all the time like this. They never use what they make because what they make is junk, just like we saw with Steve Benner. He took this and he reacted with this sodium amido phosphate, and then he added this at room temperature, and so it was quite basic. So he has to lower the pH value and he lowers it to pH 7 over a period of 4 hours by adding ion exchange resin. Where do you get an ion exchange resin on early Earth? A batch of the DAP was added and pH 7 maintained as before over a 24-hour period. Subsequently, the pH of the reaction mixture was lowered to 6.5 and maintained over 24 hours. It's hard to carefully lower pH values. I'm telling you, you take water, you just add 1 drop of HCl to it, boom, the pH just drops dramatically. Here you have to slowly add ion exchange resin. This is full of human involvement, and Steve Benner says his chemistry doesn't have human involvement because he committed it to Krishnamurti. Yeah, he didn't do it, but you see how this is cheating? This is cheating. Your own words, Steve.
Ignorant or lying or stupid or perhaps all three.
I didn't say this. These are the words you use. This is a self-fulfilling prophecy for you, Steve. This is the chemistry that's involved. In addition, a reaction mixture was diluted with 10 mils of aqueous triethylamine formate, filtered and washed 3 times. The washings were combined and subjected to ion exchange chromatography, so they're going through an ion exchange column and fractionated, and then they do the characterization of this. This is what's involved. This is the type of hands-off chemistry that we're talking about here. This is the type of hands-off chemistry that Steve says he has. Yeah, his hands are off, but Krishnamurti's hands are on. Let me tell you what's involved in making that DAP reagent. You need the preparation of this DAP. Where'd they get DAP? Well, they bought it, or they made it. So here's how you have to make it. You take phenylphosphorodiamidite. This compound you can't get from a prebiotic earth. You buy it. There's no way that they've shown to get, these aerial rings on a prebiotic earth to be able to do this. And it was suspended in 4 molar sodium hydroxide. I mean, that's really basic, but okay, we'll give them that. And in ethanol. Ethanol is not a prebiotic solvent. Dichloromethane is not a prebiotic solvent. Vacuum for 2 days is not a prebiotic method. So this is not made by a prebiotic route. You'd have to make this by a prebiotic route for this to be relevant. So you look up the synthesis of this. This is in the Watanabe paper in 1986. And Watanabe cites a paper from the late 1950s. It's not prebiotic by that route either. So this is just, fine Waldo. I mean, I'm going to wear you out by sending you to all these references. And then when you go there, it's not prebiotically relevant anyway. Steve, that was in my video series, and you watched my video series. You didn't watch it, or else you'd know that was prebiotically relevant. And I've even written about this. Have you ever read my writings on Origin of Life? Here's my complaints on this, and I wrote about this in the journal Inference in a paper called Much Ado About Nothing. And I say a third shortcoming lies in justifying the use of DAP to make the 5-hydroxyl into a suitable leaving group. In this study, DAP is described as a potential prebiotic phosphorylating agent. The authors have used the same reagent in several of the previous papers where they described it in the same manner. Any attempt to discern the prebiotically relevant synthesis that was used to prepare DAP quickly turns into a wild goose chase. Readers of the article under review are referred to an earlier Krishnamurti paper from 2017 that in turn cites the article by Albert Eschenmoser published in 2000. By the way, that's the one we were just talking about. It was Krishnamurti and Eschenmoser, 2000. Eschenmoser, for his part, cites a 1986 article by Watanabe and Sato, even though they did not use a prebiotically relevant route. Eschenmoser also cites a 1957 article by Clement entitled, and here's the German name, Contribution to the Knowledge of Mono, Amido, and Diamido Phosphoric Acids. This paper has nothing to do with prebiotic chemistry. It seems that DAP has become so ubiquitous in Origin of Life research that it is now simply accepted as being prebiotically relevant. Any effort to retrace the research that underlies this assumption leads nowhere. See, these guys send you on a wild goose chase. Well, we use these reagents which are prebiotically relevant. They're not. They're not. You go look them up. There's no history in this to go back to a prebiotically relevant synthesis. Here's the paper they refer you to in the 1950s. It has nothing to do with prebiotic chemistry. And this is what you're talking about, Steve Benner? Shame on you. The ribose you made was junk. And then you say your people don't need to have pure ribose or constant human intervention to get these things. Not so. There was constant human intervention because you cite Krishnamurthy's work to do this. Krishnamurthy did the human intervention part, and we just read his experimental. Then Biondi makes long molecules and you don't even have to have pure systems. That's a bunch of garbage. That cannot happen. You cite how Biondi is making these long RNA molecules, and Tour may not even be aware of it. How could I have been aware of it, Steve? You had not published that paper when you made this video with Dave Farina. It was not until 13 months, over a year after the making of the Farina video, the Biondi paper comes out. And you say, well, Tour may not even be aware of it. And Dave agrees with, James is not really aware of current things. He only knows older things. How could I be aware of it? It was never in the literature. It didn't come out till over a year after Dave's video. You, Steve Benner, reference work and say Jim may not even be aware of it. You reference work that isn't even in the literature. Your ribose is junk. You never even used the ribose that you made because you couldn't have. And then you talk about making triphosphates, and you don't have to have pure materials there.
She does not need either pure starting materials or constant human intervention.
You cannot have impure systems. You don't demonstrate it, and that is absolutely impossible based on Carruthers' equation. You are doing a polymerization of what's called an AB polymerization. You have a 5-triphosphate on a nucleotide. You're trying to couple this with a 3-hydroxyl. 5 and 3-hydroxyl on the same molecule, so it's called an AB-type condensation polymerization. You absolutely have to have pure starting material. So when you make this claim that you don't need pure material, number one, you didn't demonstrate it with impure material in your paper. Number two, it is utterly impossible, scientifically impossible, based on what we know of condensation polymerizations. Violation of Carruthers' equation. It's scientifically impossible for this to be done without pure material. You have to have everything triphosphorylated. You have to have no other exogenous alcohols in there, no other amino acids that happen to be floating around. This is what origin of life people do. When they want amino acids around, all 20 of them are available. When they can't have amino acids, it's totally... That, Steve, is not true. That absolutely is not true. There was constant human intervention in the intermediates. And even those intermediates you didn't use. You bought your ribose triphosphate because you couldn't make it. And they were ultra pure, and you ultra purified your little rocks. You could not have gotten there any other way. What you're saying is not true. Ask any polymer chemist. 20 years of my career, I dealt with condensation polymerizations. I worked on condensation polymerizations. Any polymer chemist will be laughing at you to say that you can be using impure materials for these polymerizations.
He then wants his audience to conclude that anyone who suggests otherwise is ignorant or lying or stupid or perhaps all three.
What would you call such comments like ribose can now form and we don't need lots of human involvement?
Rocks can make long RNA molecules. She does not need either pure starting materials or constant human intervention.
And your suggestion of a statistical impossibility when you say that you can get these polymerizations with impure material. Would you say that anyone suggesting such things is
ignorant or lying or stupid or perhaps all three?
You call such a person that says such unsubstantiated, statistically impossible and loose comments as